All right, so do you remember the definition of a function? Okay. So we can think about it as a mapping. You can think about a graph. You can think about a set of ordered pairs. There's a whole bunch of different ways that we can represent it. But the main thing that you need to remember is that if we're talking about a function, the thing that you absolutely must have is that each x value corresponds to only one y value. Okay? Think about it as each person has only one birthday. It's okay for people to share birthdays. Two x's can go to the same y, but what you can't have is one person having two birthdays. No x can go to two different y's. So they'll show you some pictures like these blue and pink boxes down at the bottom. They will show you some ordered pairs like this. They'll write a relation, which is they'll write the set of ordered pairs, and they'll say, hey, is this also a function? And then they will do equations and say, are these functions? All right, so let's go back to my PowerPoint. All right, so I pulled several. So determine whether each relation represents a function. For each function, state the domain and range. Okay, so for the first one, you've got this box that says father, this other box that says daughter, and Bob is matched with Beth and Diane, John with Linda, Chuck with Marcia. Okay, wait, is it a function? You say no. Why is it not a function? Because Bob is matched with two daughters. Okay, to be a function, each element from the first set can only match with one element of the second set. Okay. Do the same thing when they give it to you like this as a list of ordered pairs. You're looking to make sure that if any of these x's happen to repeat, like for instance the -4, that they don't have different y values. And here they do. This is another no. Okay, because the -4 is matched with 4 and the -4 is matched with 0. Can't have that. So for this last one, -2, -1, 0, 1. Cool. Each of our x values is paired with exactly one y value. This is a function. And if they say, what's the domain? And they give you the set of ordered pairs, you're going to pull off all of the x values from the ordered pairs, preferably write them in order. So what? -2, -1, 0, 1. For the range, do the same thing. Pull off the y values. Now, they're not in order when I first pull them off. I get a 16, a 4, a 3. Then the 4 repeats, so I don't have to write it again. Put them in order. So 3, 4, 16, just to put it in a nice form. Okay. So you're looking to see what each x value is matched with. Okay. Now, do you remember when we talked about domain? Okay. We talked about domain of functions several times. This is where we want to look and see what values is it okay for us to use for x. So always take just a second and look. Usually there will be just a plain old polynomial in there somewhere. If it's a plain old polynomial, you can plug any value you want in for x. So if I ask you what the domain is, you tell me the domain is all real numbers. Okay? Do you remember this notation? The set of all elements x such that x is an element of the reals, and that r has a double bar on the side. Okay? So always look for something like that. Okay? A polynomial, you can use anything you want. Domain is all real numbers. Okay? Then I usually go in and I start looking for the fractions. So look at this next one, this h of x. Okay? Are you familiar with that notation, by the way? This h of x, f of x, g of x, f of x. That's the fancy notation that we use to denote this expression is a function. Okay, you've seen anytime we write, y equals, and we have our equation, whenever we replace the y with f of x or g of x or h of x, what we're saying is, hey, this equation represents a function. Okay, so h of x, it's a function. It's a rational function. When I look at this, I say to myself, wait a minute. That x squared minus 4 on the bottom, how does that factor? X plus 2, x minus 2. And I say to myself, well, x had better not be -2 and x had better not be 2. So when I say what's the domain, what values can I use? you say you can use anything you want to, except don't use -2 and don't use 2. So the domain is the set of all the elements x such that x does not equal positive or -2. Okay. All right, now I don't think we've done a square root before. Think about it for a second. So if we're looking at the square root of 1 minus x, and we want to have real answers, okay? Not complex answers, we don't want any i's in this. Okay? So what do we know about the stuff underneath, the expression underneath the square root, if we don't want any imaginary answers? Okay? We say to ourselves, well, the 1 minus x has to be bigger than or equal to 0. Or otherwise I'm going to get like the square root of -16 or the square root of -9. I'm going to get an imaginary answer. Okay, so whenever you see a square root or any even root, take the expression from underneath, okay, set it greater than or equal to 0. Okay? Now it'll fall out really quick. If I move the x to the other side by addition, I get 1 is bigger than or equal to x, which is the same thing as x is less than or equal to 1. So this is cool as long as I use x's that are less than or equal to 1. What's its domain? Any number less than or equal to 1. Okay. Now, do watch out for ones like this last one, because they will try to get you because they'll try to mix them together. Okay. So, you know you can't have division by 0, right? So looking at this, you know x had better not be what? It better not be 4, right? Okay. Also, you've got that square root. Well, we just said that the stuff underneath the square root can't be negative. It's got to be bigger than or equal to 0. So does it make sense if I put both the things together? So I've got a root and I've got a fraction. And so if I have to think about both of those things, what I know is that x minus 4 has got to be bigger than 0. Does that make sense? If I just had the radical, I'd say x minus 4 has to be bigger than or equal to 0. But that radical's sitting in the bottom of a fraction. So since it's sitting in the bottom of a fraction, it can't equal 0. So all I can have is the x minus 4 bigger than 0. Think about that. Make sure you understand that. Okay? If I add 4 to both sides, I get x is bigger than 4. And I say I can use any x's that are bigger than 4. That's my domain. Okay. All right. Oh, so now we're going to do this. Let's go back to the book for just a second. I want to make sure we're cool with the notation. All right. So we said a minute ago that functions are often denoted by different letters. Okay. So you'll see f of x, h of x, s of t, v of w. There's nothing special about the f and the x. That's just the one that we tend to use a lot. Okay, it's read the value of f at the number x. And so you want to think, whenever you see something that looks like this is saying when x is 3/2, tell me what the y value is. Okay, and we're going to do some examples. Make sure you read through this really carefully. I need you to be real comfortable with with all of the different terms. X can also be called the independent variable, with y being the dependent variable. Again, don't get hung up on the x and the y. We can use all sorts of different letters. Okay. All right, so we're going to do one of these. We are also, and that's just their example, we'll do the difference quotient. Important facts about functions. For each x in the domain of f, there's exactly one image f of x in the range. However, an element in the range can result from more than one x in the domain. Well, that's true. That's what we said. Each person can have only one birthday. It's okay for two different people to have the same birthday. F is the symbol that we use to denote a function. It is the symbolic of the equation or the rule that we use to get an x in the domain of f of x in the range. Okay. If we use x and y, x is the independent variable, f of x or y is the dependent variable. Okay, cool. We're cool. All right, we got all that. All right. We'll do some more domain. And then we will do some sum difference product. Okay, we're good. Let's go back to the PowerPoint. Okay, so take this function, f of x equals negative 2x squared plus x minus 1, and find all of these things. Okay. All right, so A says f of 0. That means when x is 0, what is y? Everywhere you see x, substitute a 0 for it. So negative 2 times 0 squared plus 0 minus 1. That is 0 plus 0 minus 1. That's minus 1. Okay. F of 1 is B. Okay. So everywhere you see x, substitute a 1. So negative 2 times 1 squared plus 1 minus 1. So 1 squared is 1 times negative 2 is negative 2 plus 1 minus 1. That is negative 2. Get the hang of what we're doing? We're just crunching numbers. Okay? You make sure you understand the notation so that when you see f of negative 1, you know what I'm asking you to do. You know that I'm saying, hey, x is negative 1. Go up there in that function, and everywhere there's an x, write negative 1. And then you clean it up, okay? So negative 1 squared is 1. 1 times negative 2 is negative 2. Plus a negative 1 minus 1. So negative 2 minus 1 minus 1, that's negative 4. Okay. All right, so let's try D. F of negative x. Everywhere there is an x in the function, you put a negative x. Okay, so negative 2 times negative x quantity squared plus negative x minus 1. Clean it up as best you can. Can't do much with it. Negative x quantity squared is x squared. Then minus x, you don't need the parentheses, minus 1. Can't do much with it. But what I do want you to do is take a second and look. What's the difference between D, which is f of negative x, and E, which is negative f of x? What's the difference in that? Okay. Negative f of x means take your function and take the opposite of the entire function. Okay, it means negate f of x. Take every single sign in x and switch it. So it becomes positive 2x squared minus x plus 1, which is not the same answer as what we got for D, because they're not the same thing. Okay. All right, F. All right. F of x plus 1. Now I want you to be very careful with this because F and H, this one and this one, are so very important. Okay. All right. I'm going to do this in a couple of steps. My original function is negative 2 times something squared plus something minus 1. Everywhere there was an x, I just took it out and put a set of parentheses instead. Make them look like parentheses. Okay. So everywhere there was an x, I want to now put x plus 1. So I want to put an x plus 1 here and an x plus 1 here. And then I want to clean it up. Now, be careful. Order of operations says I can't do anything with that negative 2 out front until I multiply the x plus 1 times x plus 1. Because x plus 1 squared means x plus 1 times x plus 1. Okay, so what is that? X squared plus 2x plus 1. And then I don't really need the second set of parentheses. I needed them for a minute just to make sure I didn't have to watch any signs, but it's a plus in front of it, so I'm cool. And let's see, now I need to distribute the negative 2 into the parentheses. So negative 2x squared minus 4x minus 2 plus x, and then plus 1 minus 1, they add to 0. And let's see, negative 4x and a positive x, I can combine those and get a negative 3x minus 2. So negative 2x squared minus 3x minus 2. Okay, I'm going to need another paper. Let's see. Let's go back here. I need to add a page. All right, so my function was f of x equals negative 2x squared plus x minus 1. And I'm on G, which said find f of 2x. Right, I'm going to do the same thing. Everywhere there's an x, I'm going to replace it with the 2x. And I'm using the colors so that you can help keep track of what I'm doing. Everywhere there was an x in the original problem, I replaced it with 2x. And now I'm going to go in and I'm going to clean this up. 2 squared is 4. X squared, then plus 2x minus 1. I can leave off the second set of parentheses. And then negative 2 times 4 is negative 8x squared plus 2x minus 1. Okay. All right. And one more. We need to do f of x plus h. Now this one's really important, so pay close attention. Okay, again, it's negative 2 times something squared plus something minus 1. This time, the something is an x plus h. So everywhere there was an x, I replace it with x plus h. Now I clean it up. Okay, now be careful. What is x plus h times x plus h? Can you do that? That's what, x squared plus xh plus xh, so plus 2xh plus h squared. Then I don't need the second set of parentheses. And I need to distribute the negative 2, so negative 2x squared minus 4xh minus 2h squared plus x plus h minus 1. Cool. Okay. So now you're going to do several of these and it might get a little bit tedious, but really kind of focus on what you're doing. Make sure you understand why you're doing what you're doing, why you're substituting each piece. Okay. All right. So there are several of these in the same section where they're having you do the addition, subtraction, multiplication, and division with the two functions. It works out so beautifully. Notice that here it says find the following for parts A through D, also find the domain. I'm going to do that first. Okay, so I'm going to come down here and I'm going to look at f, and I'm going to say, f is 2x plus 1. What did we just say the domain of something like that is? Okay, it's a straight line, right? It's a polynomial function, first degree. You can use anything you want to for x's. Domain is all real numbers. Same thing for g. Domain is all real numbers. Okay. So the very cool thing about this is that if I say find the domain of the sum, the difference, or the product, well, if the domain of f and the domain of g is all real numbers, the domain of the sum is all real numbers. The domain of the difference is all real numbers. The domain of the product is all real numbers. For the quotient, the domain is all real numbers except, don't forget you can't divide by 0. So let's see. Let's write it out and I'll come back and fill in that blank in just a second. All right. So I want to do f plus g. So that's 2x plus 1 plus 3x minus 2. And then I make it look pretty. 2x and 3x is 5x. Plus 1 minus 2 is minus 1. That's f plus g. For b, I need f minus g. Notice how I'm writing it without the double parentheses and the f minus g of x. That is acceptable. It's totally fine. Okay. So f minus g, it's 2x plus 1 minus 3x minus 2. Notice I put some parentheses in there because I want to be careful. Okay, so that's 2x plus 1 minus 3x plus 2. So 2x minus 3x is negative x plus 3. C, f times g. All right, so 2x plus 1 times 3x minus 2. And depending on what you're doing, sometimes it's fine to leave it like that. Sometimes they will want you to go ahead and multiply it out. I'm going to go ahead and multiply it out here just to be safe. 6x squared minus 4x plus 3x is minus x minus 2. Okay. And then the d, that's the one I was trying to get to. F over g literally is 2x plus 1 over 3x minus 2. And you can't do anything else with that. It's 2x plus 1 over 3x minus 2. So go back up there to the domain. It's all real numbers except what? 3x minus 2 can't equal 0. So 3x can't be 2. X had better not be 2/3, is that right? So up here, all real numbers except x cannot be 2/3. Okay. Now, E, F, G, and H. So E is F plus G of 3. So there's a couple of ways you can do this. You can plug 3 into F, 3 into G, and then add your two answers together. Or you can make use of the fact that we've already got F plus G right there and plug 3 into that. So 5 times 3 minus 1, 15 minus 1, that's 14. Okay. F, we want F minus G of 4, which means plug 4 into the difference. Well, here's the difference. So minus 4 plus 3, that's negative 1. C, oh, excuse me, G, F times G of 2. Multiply F and G together, plug in 2. So here, so 6 times 2 squared minus 2 minus 2. So 6 times 4 is 24, minus 2 minus 2, that's 20. And then the last one, H, F over G of 1. So 2 times 1 plus 1 over 3 times 1 minus 2. That's 2 plus 1 is 3 over 3 minus 2 is 1. That's 3. Okay. So again, notice it's some really cool number crunching. You just got to be real careful. Make sure you take your time and think through it. Okay. All right. Now, 3 more slides, and these are so important. Do you remember when we did the factoring sections back in the appendix, and there were the problems that I said, hey, these are so important for calculus, you're going to have to clean this up, you're going to be doing problems in calculus, and you're going to get to something that looks just like this, and your teacher's going to expect you to know how to clean it up? Okay. Well, the difference quotient is something else that is so important for calculus. I don't know if you're familiar with it, with calculus at all, but a lot of what you do is finding derivatives. And this notation right here, f of x plus h minus f of x over h, where h is not 0, that is an important component of the definition of derivative. So you have to be able to deal with these symbols. Okay, so I want to show you 3 different examples. And I do want you to make sure that you understand that if I say difference quotient, I mean this thing right here. Okay? Because I might not necessarily say, oh yeah, the difference quotient is f of x plus h minus f of x over h. If I say difference quotient, I expect you to memorize this formula, just like you know the distance formula, just like you know Pythagorean theorem, just like you know how to find a midpoint. If I say difference quotient, you know this thing. Okay? All right, so let's start with a cute little quadratic. So f of x is 3x squared minus 2x plus 6. And I'm going to come right below it, and I'm going to write f of something. It's the same thing. So it's 3 times something squared minus 2 times something plus 6. That trick where I was taking the x's out and putting parentheses. Okay. So I'm going to start, and I'm going to do this part first, the f of x plus h. So everywhere there was an x, I'm going to write an x plus h. So I'm going to have 3 times x plus h quantity squared minus 2 times x plus h plus 6. Okay, that is just the little part that I underlined in red. Then I need to do this part, this minus f of x. Do you remember when we did that? It was the same thing as take the opposite of the whole function. And I'm going to write it out with parentheses because I'm going to make sure I don't leave anything out. And then don't forget you've got that whole divided by h thing. Do not get in the habit of not writing it, because as soon as you stop writing it, you will forget to put it back. Okay? So now I have to clean this up. My goal is I want to get rid of the baby h that's on the bottom. I do not want to be left with a fraction that has an h by itself on the bottom. Okay? So I'm going to clean this up. All right, so 3 times, okay, x plus h quantity squared. That's x squared plus 2xh plus h squared. Remember, because this is x plus h times x plus h. And then I've got that minus 2 times x minus 2h plus the 6. Then take the blue minus into the set of parentheses, minus 3x squared plus 2x minus 6 all over h. Now while this looks like it's going nuts, it should also be collapsing. See this plus 6 and that minus 6? They add to 0. This minus 2x plus 2x, they add to 0. So anytime I start seeing stuff like that, I'm going to go ahead and simplify it as much as I can. I'm going to distribute my 3. So 3x squared plus 6xh plus 3h squared. Then what? Minus 2h minus 3x squared over h. And this add to 0. So I've got 6xh plus 3h squared minus 2h over h. So remember I said what we want is to get rid of the h's on the bottom. We do not want the baby h in the denominator all by itself. Notice how convenient every term on the top has an h in it. Okay. So I'm going to put an extra step in here just to show you what I'm doing. Every term on the top has an h, so I can factor an h out. Then I'll have h times 6x plus 3h minus 2. And I can cancel h on top, h on bottom. I could have done it from this form, but I don't want you to make a careless mistake and forget something. Okay, so that's why I showed the factoring it out. Final answer for this is 6x plus 3h minus 2. Totally fine for that h to be in there. It just couldn't be on the denominator by itself. Okay. All right, let's do one with another fraction. Let's do some fractions in fractions. Okay. All right, so again, think about this as 1 over something plus 3. So the first part is I want to do the f of x plus h. So I want to plug x plus h into the parentheses. So I get 1 over x plus h plus 3. And I could put parentheses or not. It doesn't matter. Okay, it's fine either way. There's nothing that's being multiplied into any parentheses, so we don't necessarily have to put that x plus h in parentheses. Okay. Then I need this part, minus f of x. So minus 1 over x plus 3. Right? So minus f of x minus 1 over x plus 3. Again, with the parentheses, as long as I clearly put the minus, the subtraction in front of the fraction, I'm cool. Then over h. All right, so this looks nasty, right? You don't want to leave the h on the bottom by itself. So the only thing to do is to do like you would with any other complex fraction and try to combine the red and the blue fractions in the top. Get a common denominator, add those together, hope and pray stuff is going to cancel and reduce. Okay, so that means I need a common denominator between the red fraction and the blue fraction. So one of them has an x plus h plus 3 in the bottom, one of them has an x plus 3 in the bottom. So remember that whole common denominator thing? This one needs an x plus 3. If I put it on the bottom, put it on the top as well. This one needs an x plus h plus 3 on top and bottom. Okay, let's clean that up. So we get x plus 3 minus x plus h plus 3 over common denominator of x plus h plus 3, x plus 3, all over h. Good grief. Right? All right, so let's go at that numerator, see what we can do. That's what, x plus 3 minus x minus h minus 3 over x plus h plus 3, x plus 3, all over h. All right, look what happens. Positive x, negative x. Positive 3, negative 3. So what I actually have is I have negative h over x plus h plus 3, x plus 3, look, divided by that baby h. I just rewrote it instead of writing it with that bar. I rewrote it with a division symbol because I know I can then instead of dividing by h, I can multiply by 1 over h, and that will finally let me reduce the h's. Final answer for this is going to be a negative 1 over x plus h plus 3, x plus 3. That h on the bottom is fine because it's connected by addition to other pieces. You just can't have a baby h by itself down on the bottom as a factor. Okay, so this is your final answer. Okay. All right, and I want to do one more because I want to make sure that I have shown you all the different possibilities. Okay, so let's do this one. Okay, so, oops. F of something is the square root of something plus 1. So f of x plus h is the square root of x plus h plus 1. Again, I could put the parentheses around the x plus h. This just gets really messy, so I try to keep as many extra symbols out as I can. Okay. Then I need the minus f of, the minus f of x, so minus f of x over h. Okay, so up until now you've been told never leave radicals in the bottom of fractions, right? Every time you had a square root in the bottom of a fraction, you rationalized it, you made it whatever you had to do to get the radical out of the denominator. Well, when you get into calculus and you start looking at the formal definition of derivative and you're doing these difference quotients, what you need is that h on the bottom, okay, to go away. So from what we've done, you know, we've formed the difference quotient, okay, but the problem is that h on the bottom. The h on the bottom cannot stay there. So where usually we rationalize denominators to get the radicals out of the denominator, we are going to rationalize the numerator so that the baby h will not stay down on the bottom by itself. Okay, so I am going to multiply top and bottom by the conjugate of the numerator. Okay, all right, so yeah, I'm going to put parentheses here. Okay, so I'm going to multiply on the top and bottom by the conjugate of the top, which is the square root of x plus h plus 1 plus the square root of x plus 1. Remember conjugates? Okay. All right, so exactly what you see, except you change the sign in the middle. All right, so now I've got on the top, when I do first times first, square root times square root, I get the x plus h plus 1. When I do outer times outer and inner times inner, those add together to 0. And so then I do last times last, I get minus square root of x plus 1 times square root of x plus 1 is x plus 1. I put the parentheses because that minus sign I have to subtract the whole entire x plus 1 over h times the square root of x plus h plus 1 plus the square root of x plus 1. Okay, on the top, x plus h plus 1 minus x minus 1 over h times square root of x plus h plus 1 plus square root of x plus 1. Positive 1 and negative 1 add to 0. Positive x and negative x add to 0. See what we have? We have h over h times square root x plus h plus 1 plus square root of x plus 1. I can reduce the h's and say it's 1 over the square root of x plus h plus 1 plus the square root of x plus 1. That is your final answer. It's not the usual form. We don't usually leave the square roots in the bottom, but because of what this is, because it is a difference quotient and what it would be used for, what you have to think about is the h in the bottom by itself. It's more important that we get rid of this. Okay. So we rationalize the numerator, and I end up with our final answer looking like this. Okay. Hope this was helpful.